Hey everyone, it's Libby from Hackster. This morning I've got Zach Homuth from Upverter, and this morning he's going to be giving us a presentation just about Upverter and what it can do. It's a PCB design tool, and he's going to be sharing a schematic with us. So I'm just going to go ahead and hand it off to Zach right now. So Zach?
Hey. So this is Zach, and I'm from Upverter, and we recently worked with the guys at Hackster to embed Upverter into the Hackster ecosystem, and so now anybody that's working on Hackster design or project can also link it with an Upverter PCB schematic layout design. And they can use the Upverter tool from right inside the Hackster ecosystem. And so we thought it would be kind of a cool thing to show you guys a little bit of Upverter, how it works, what you can do using it. And to do that, we're going to design just a really simple RFID Arduino shield. And I guess this is a very popular thing in the Hackster ecosystem right now. There's a lot of people hacking on RFID, and obviously Arduino shields have always been cool. And so we're going to today kind of go through Upverter and put together an RFID shield, and then we're going to leave a bunch of time, Libby, I don't know, 20 minutes or so at the end for questions, but feel free to ask questions as we go. I guess put them in the chat. And then if I don't notice them, Libby will grab me and we'll answer your questions as we go as well. So anyways, to get started, sorry, say that, Libby?
Oh, I just said I'll keep an eye on the questions.
Amazing, cool. So to get started, everybody can see my screen. This is Upverter, and so this is the very first tool that I'm going to show you today inside of kind of the Upverter platform, and it's a system design tool. And the idea behind a system design tool is ignore all the kind of nitty-gritty stuff, ignore the capacitors and the resistors and what has to hook up to what and exactly what way, and just kind of zoom out and do a really high level block diagram view of what you're working on. So in this case, we're going to take an Arduino, which I've dropped down here. We're going to hook it up to an ID12, which is an RFID chip. That ID12, we're going to hook up to an antenna, an LED, and a speaker. So whenever it makes a connection, it'll blink the LED, and the speaker will make a buzz. And then we've got it already has an internal antenna, but we've got a spot for an external antenna as well. So we're going to put that on the board so that we can experiment and see which one works better. And then the original design we based this on, which is the RFID shield by Build Awesome, has a temperature sensor on it. And so we're going to include that temperature sensor as well, but that actually just hooks up to the Arduino. So anyways, that's what we're doing today, is this design here. If you want to use a system design tool, it's super easy. You go up here in the top left, and you can open up this kind of add block tool, and these are all just super generic blocks that you can add to your design. So if you want a button, right, you take your button, you drop it down in your design, and then you say, okay, well, my button has to be hooked up to my Arduino, so I'm going to go over here, I'm going to draw a line between the two of those, boom, maybe I move it over here because it looks a little prettier, and there we go. Now I've added a button to my design. So that's how the system design tool works. Most people use this just to get started, like, okay, I'm going to build this thing, but what do I need? What are my major parts? Okay, it's going to have an Arduino, it's going to have this chip, it's going to have that chip, but like I don't have to worry about the block diagram, the reference diagrams and laying out resistors and capacitors. I can just kind of focus on the high level stuff. So that's what the system design tool is for. So anyway, that's that. We're going to move over to the schematic tool. I don't know if anybody has any questions on that so far, but that's how the system design tool works. We'll move over to the schematic tool. And so the idea behind the Upverter schematic tool is it's kind of the same as any other schematic tool with just a couple of notable differences. So if you've used Eagle or KiCad or anything like that, this will be really familiar to you. Big big differences in Upverter are we don't make you work with a sheet. Most other tools make you work with like an 8.5 by 11 piece of paper because they expect you to print it out. We kind of think we're past paper, and so we give you an unlimited canvas that you can work with. And so you don't have to worry about what's going to be on page 1 and what's going to be on page 2. You can just kind of design in open space. So that's kind of big difference, number 1. Big difference number 2 is Upverter's collaborative. Up here at the top, you can see who's working on the design. And so this lets you, if you have a bunch of people working on a project together, or if maybe you're a junior engineer and you've got a friend that's a little bit more senior, it lets you get them to collaborate on the design with you. So you can invite those people in, you can all work together at the same time. Feels very much like a Google document or something like that. Everybody's kind of working together, and the design, just kind of emerges out of that, rather than you having to like do your work and pass it over to Frank, and then Frank passes it to Jim, and like you don't have to deal with that. You can just, everybody can work on it at the same time. So that's kind of big difference number 2. And the big difference number 3 is we have this giant parts library, and it's all, it's all in the cloud, and it's all powered by all of the other people that use Upverter. So when you go in here to look for parts, you can see that there's 1.37 million parts in the library for you to pick from, and other people have used these parts, and you can trust someone, and and others you can make yourself. And it's just kind of this power of collaboration, this power of having this whole community of people working on the design, that you just get this big, giant, huge parts library that you didn't have to make yourself. And that's kind of big difference, number 3. But we'll go through the schematic tool right now. So this is our design, and I've kind of fleshed it out so that you guys don't have to spend 30 minutes watching me do a schematic, because that's kind of boring. So I thought we would just kind of piece the last couple of pieces of the schematic together. Over here, we've got our configuration for what mode the ID12 is in, and if we need to reset the RFID chip. We've got the future pin and the card present pin both broken out to these jumpers so that we can hook them up to other things in the future if we ever want to use them. This is our Arduino. This is our ID12. Up top here, we've got this external antenna circuit, again, jumpered in case you want to disconnect it or reconnect it. Down here in the bottom right is our temperature sensor, and here is our LED and speaker circuit. So we're just going to quickly hook these all up to the ID12 and the Arduino. So the way Upverter works pretty easy. Click, you can drag stuff around, you can lasso stuff and move a bunch of things at the same time. That all works just the way you'd expect it to work. This tool over here on the left is our net tool. This is how you hook things together. So for example, if I want to take this antenna circuit and hook it up to the ID12, I can move the ID12, I can hit the net tool, and I can hook these traces up, and there we go. Now we're connected. Right? Same idea with this LED circuit. I can zip that over here to this resistor, and there we go. We're hooked up. We tend to encourage people to design with what we call flags or connection markers. They just make the design a lot more readable and kind of easy to see. And so that's what this is. So this is 5 volts. So it will connect to everything else with the name 5 volts in your whole design, and that's how that works. So this 5 volts will be hooked up to this 5 volts, so on and so forth. So we do that just because it's way tidier and way neater and cleaner to do that. The other nice thing Upverter does is as you move stuff around, it will kind of intelligently redraw these nets so that you don't kind of get this big mess of wires, and you can kind of still see what's going on. So I'm going to pull the Arduino up here, and we're going to use D0 and D1. And this is just an Arduino Shield module that we have inside the Upverter library. So if you ever want to build an Arduino Shield, you can actually just grab this part right out of the library, and it comes with everything you need. It comes with the headers. It comes with the mechanical drawing of the shield. I'll show you that in a second when we go to the PCB. It just comes exactly the way that you would need it to be to make your own shield. Anyways, I'm going to finish hooking this up really quick here. So we're going to take ground, hook it up, and then I spec'd out I spec'd out these to these jumpers over here, so that in case we ever want to use them, these are features of the chip that are not used in most cases. But I've got this net, I call it card present, and it's the card present detection of the ID12, and we're just going to hook it up to CP here, and then we're going to do the same thing with future. And you can actually copy paste, and so I'm going to copy and paste that, and now I have that same hookup. Whoops, sorry, I got to go up one more. I got that hookup to the future net. So there we go. We're now all hooked up. Oh, I guess, sorry, I lied. I have to hook up reset and mode as well. I guess any questions on any of this so far? Is this kind of making sense to everybody?
I don't see any questions so far, Zach, so I think we're good.
Looks like we're doing all right. Cool. So anyways, now we're actually all hooked up. I apologize for that. So in terms of other things that the schematic editor can do, now that we've, oh, I guess we have to hook up temperature too. Now that we've got everything hooked up here, other stuff it can do, if you go up here on the right, you can see that you've got the undo redo history for every action that I've done on this design since the beginning of time. And if I close this browser window and then open it back up, this will still be here. One of the kind of neat things about Upverter is that it has this unlimited history because we store everything in the cloud, and that lets you do neat things like try something out at the end of the day, go to sleep, shut your computer off, go to sleep, think about it, wake up the next morning and be like, no, I didn't like that. And all you have to do is hit undo. You don't have to like roll back to another version. You don't have to have saved a copy. You don't have to have done anything weird like that. You just hit undo the next time you go into your editor. You can also fork your design at any point in time. So like, let's say you want to try something out, and so you just take the design state, you roll it back, you say, okay, I want to try something different at this point in time, and then you take a fork of that. You can do that in Upverter just like you would with like a GitHub project for software. Other kind of tools we have on the left-hand side here, we have this thing we call issues. So built into Upverter is a task management system, kind of, sort of. So if I wanted to say, okay, look, I still got to hook up 3-volt 3 and 5 volts because I don't have those hooked up right now, I can do that. And over here on the right, you can see this little issues, and I can create a new issue and say hook up power. And I can assign that to anybody that's collaborating on the design. So I can go into this issue and I can say, okay, I'm going to assign that to myself. It's critical. And I can have a little conversation here with everybody else that's working on the design about how the best way to hook up the power in the design is. And so you can do this for, obviously it's pretty simple in this case, but in the case of like, a pretty complicated design, you're trying to pick between which part you want to use. You can do that all inside the editor through this issues, and you kind of have that whole collaborative discussion inside the editor. I'll just show you quickly here on the right-hand side. So I've got my history. We have this thing called the concierge, and the way the concierge works is if you ever need a part for your design and you just can't find it. So like you go in here and you search for a part number and you're like, shit, okay, it's not in the library. You can request it from the Upverter concierge, and the way that works is you click request from the concierge, you say, okay, it's a TI, whatever, request my part, and we'll confirm how much it's going to cost, and we give people free credit when they join up for accounts so they can try this out. But we give you this placeholder part, and this will sit in your design while the concierge works on making the part for you. So they'll make the symbol, they'll make the footprint if you want them to, they'll make the 3D model, and that'll all show up right in your design. And you don't have to do a thing. You don't have to read the data sheet. You don't have to open up a part editor. You don't have to do any of that. And we call this the concierge. And you can see here now that it's been queued for symbol creation. So somebody is actually going to go and work on and make this part for me. It takes about 24 hours in most cases. But if you needed a bunch of parts, you could just go bang, 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 request all these parts. And then what we like to do is we give you this stub. And so you can put this in your design and then put all the parts around this that are eventually going to be hooked up to this part. So it's all kind of ready to go. And you don't have to, you don't have to like make the part, kind of switch modes to component creation, then go back to your schematic, try to remember what you were doing. You can just do the whole schematic. And then by the time you're finished the schematic, probably some parts will start being finished and delivered by the concierge. So I'm just going to delete that because we don't need that right now. But that's the way concierge works. We're trying out some new concierge services right now. So one of them is a PCB layout concierge. So if you click this button, we'll tell you how much it costs to get an expert PCB layout person to do your layout for you. And that's our layout concierge that we're starting to experiment with. So so far it's going pretty well. We have a scripting editor, and we're changing our accounts right now so that free users get access to our scripting environment. So in the very near future, you'll be able to use this to write scripts inside the Upverter editor, and it's all just JavaScript, and you can tell us to do whatever you want, same as you would write a script for any other CAD package. And so we have one that renumbers the reference designators as kind of a sample. So that's the scripting editor. I showed you issues already. Property inspector is exactly what you expect. You pick a part, and it just shows you the details about that part. Constraints, this is kind of a cool thing we do, where if you make a mistake or something that we don't think is manufacturable, we're going to warn you about it. So if I just drew a net and I just left it there and I didn't hook it up to anything, we're going to turn it red and we're going to be like, that's probably not right. It's unconnected. And it's going to show up in this list of constraints. So if I go here and say, show me my schematic constraints, it's going to say, this is busted, this is wrong. And I can ignore it and the red dot will go away. Or I can, fix it and the red dot will go away. So if I take it and I hook it up to another net, that red dot will go away. It'll get out of my list instantly. And every time you make an action, we check your design kind of in real time to make sure that the things you're doing are correct and manufacturable, just kind of as a little safety blanket. We want to make sure that people who do designs in Upverter have the best kind of results when they go to manufacturing, and that's why we do that. Last but not least, down here at the bottom are the net list and the part list. And so I got to close a few of these so you can see them. Net list and parts list do exactly what you would expect them to do. If you click on any of them, they will warp you to that part of the design so that you can see what's going on. So if I want to go to the antenna, it'll take me to the antenna. If I want to see this capacitor, it'll take me to the capacitor. If I want to see the 3-volt 3-net, it'll highlight the 3-volt 3-net. And if I keep clicking this, it'll actually bounce me around the design to all the places that 3-volt 3 shows up in my design. Same with 5. We've got a lot more 5. So I can walk through each of the places I have a 5-volt connection by clicking those buttons. Anyways, and that's kind of the schematic editor in a nutshell. I'm going to flip over to the PCB layout tool now and show you guys that. So remember I said that we've got this template inside of Upverter of an Arduino shield. This is it. So it's got these headers, and they come in exactly the right location. It's got the drawing of the Arduino so that you kind of know, where it is and the shape of it and all that. And so we're going to build our board on top of this template with these connectors already placed for us. So it saves us all that time of trying to put the connectors in the right spot to make an Arduino shield. These are all of our other parts in our design right now. You can see these green lines. These green lines are commonly called rat's nests or fly wires. They're indications of work that still needs to be done, stuff that's not yet hooked up inside the design. So these are places where we're going to have to do work and hook some stuff up still. You can see I've got all the same tools on the right-hand side that I had in the schematic tool with just a couple of notable exceptions. I've got this layer inspector now, and that lets me, I can hide everything. I can turn on just the component markers, and this will show me just the centers of where all my parts are. I can turn on just the silk screen. I can see the outlines of all my silk screen for my parts, stuff like that. And this this is very useful for when you're like routing and you're like, okay, I just want to see what copper I have on the top of my board, right? Or I just want to see the bottom of my board, right? So I'm gonna just turn on the bottom of my board. So this is all the stuff on the bottom of my board. Maybe I just want to see the mechanical details. So this is my board outline. It's pretty boring right now. But anyways, I'll leave this all on for right now, or it's not complicated enough that we really need, to dig into that. Nets list, same. Parts list, same. But we also have a pores now. And pores are these things in PCB layout where you take a whole area of a board and you flood it with copper. And you do that for resistance reasons, normally because you want ground to have a really low resistance between a bunch of points. But Upverter supports pores, pretty easy to do. We're going to use a pore in this design, and it'll show up here in this pores dialog. So anyways, tools on the left basically allow you to manipulate copper. We're going to quickly finish what we've done here in this design. Whoops, sorry. We're going to quickly finish what we've done here in this design and just kind of hook the last of it all up. So I got to show all here just so that I get all my rat's nests back. Yeah, and I have to go name a net. Okay, so we're going to run a 5-volt trace here and connect these together. And these are our jumpers for turning on and off the speaker and the LED. And then we've got some 5 volts down here as well. So we're just going to run this straight down for now. And that'll allow us to hook all these configuration jumpers up to the 5-volt nets here. So we're just going to put that right there. I'll put that. And there we go. Now all that's connected. We're going to put the card present pull up down there. Yeah, and that's our 5-volt supply for the ID12. So we're going to hook that up as well.
Hey, Zach, so we're getting some questions right now.
Yeah.
So I don't know if you want to take a look at those. There are a couple that I think we can wait to the end for, but I think that there are a couple that are more related to what you're doing right now.
Of course, yeah. So they're not showing up for me in the chat or in the questions thing here. Do you mind just reading them out?
Of course. So I'll read the ones that I think are really related to what we're doing right now. So it shows mistakes if something is not connected. Does it show voltage mismatches or plus or positive or negative connection mistakes?
Yeah, so it doesn't today, but that's actually something we are working on. The way that we're doing it is inside of our parts. So I'm gonna flip back over here, and I'm just gonna go into the ID12 for a second. And if I go into the actual part, so what's opening up right now is our component editor. This is where you would make changes to the part if you wanted to edit the part. What we're doing is we've recently introduced this thing called connection type, and this allows you to tell us if a pin is an input or an output, or it's a high impedance pin or an open emitter, power, whatever. We're going to use this information plus the name of the pin to be able to make recommendations about, like, okay, well, you've hooked a bunch of inputs together, but there's no output, or you've hooked a bunch of outputs together and there's no input, or you've hooked up a bunch of high impedance stuff or open emitter stuff and open collector stuff, but you don't have the pull up you need or the pull down you need to make that work. You've hooked power to input, stuff like that. And we're going to use this plus the net name to add a whole new set of what we call constraints, design constraints. So if I go over here to our constraints editor, we're going to add a new constraint in here where we can make those kind of recommendations based on that new pin information we're collecting. So we're trying to figure out how to do this with the concierge right now so that all that pin information gets collected into the editor. But once we have that, then yeah, exactly, we're gonna be able to tell you, okay, you've hooked 3 volt 3 up to 5 volts, or you've hooked, you know, an input up to a bunch of other inputs and there's no output. And so we're working on that.
All right. So the next one, what about through-plating, solder mask generation, and fiducials?
Yeah, so fiducials are just parts in the library. So you just grab them out of the library and plunk them down into your design. That's easy. Sorry, the first one was solder mask. What, expansion or solder?
Solder
sorry,
mask.
Libby, say it again. Yeah, so so we have a solder mask layer in. I'm going to hide everything, and I'm just going to turn on solder mask here. So so the solder mask comes with the parts in Upverter, and part of the work that goes into making a component using the Upverter component editor, or if you request a part from the concierge, is that making the solder mask layer correct, so that there's the right amount of paste, and the solder mask is expanded the right amount out from the pads and all that kind of stuff. So any part you get from the concierge, that's all going to be correct for. If you make your own part, we really recommend to follow the recommendations inside the data sheet. But the way it shows up in Upverter is just as a layer. It comes as part of the part. You don't have to do anything to generate it. You don't have to do, there's no like compile button inside of Upverter. It's all just there the second you plop down the part. And there was one other question, Libby, as part of that. What was the other?
What about through plating?
Like for plated through holes, I assume. So if you wanted to throw down a via, we've got this via tool, and you can you can say what layers you want it to connect to. So let's say you got a 10-layer board, you can say which layers you want the via to connect to. You can set the hole diameter, the pad diameter. You can configure the solder mask expansion and things like that. So that's for vias. Same exact thing for through holes, except there's just a couple of differences about whether or not the through hole is plated and whether or not it needs thermal relief to make it easier to solder. So if you wanted to put down a through hole, this is a pretty standard through hole, so I'm just going to grab that, and I'm going to zoom in on our board, and I'm going to plug it down, and so that's now a through hole. And like if I wanted a much bigger one, I could go in, and all I have to do is up this. So like let's say we want a 2mm one, so it's going to be, and I can go back and edit it because my plating diameter was too small, so I'm going to fix that. And so now you can see my plating and the hole, and like let's say we want thermal relief, and what that's going to do is if I flood it into a pore, it will, if these were the same net, that would determine the thickness of the thermal relief that gets connected between the pore and the through hole. Any other questions, Libby?
Yeah, so we've also got, is layout snapped to a grid?
It is, but it's not very enforced, and you can kind of control the way that you want that to happen. So right now, my grid is 0.025mm grid. So if I zoom in, you can see that it's quite small. So I'm on that grid right now when I place parts, but I can also turn my snapping. I don't know if you can see, it's a little small down here, but I can turn my snapping to be grid-based snapping, guide-based snapping. And so guide-based snapping is when I move a part, we're going to show you there. See that yellow line that popped up? That means I'm centered with that part. So I'm going to snap to that. If I wanted to make it snap to the grid, I just change that, And then if I make my grid really big, so like let's say, you know, let's do that. And if I grab this part and move it again, it'll just snap to the grid points there. See how it's just kind of chunking between the grid points there. So it's really up to you. It's however you prefer to do your layout. I'm going to go back down to my really small grid just because I prefer to lay out this way. But it's however you want to do it. So yeah, but it is supported. Any other questions?
Yes. So we have another one that is, how are you moving parts around? How accurately?
Yeah. So when I'm moving parts around here, I'm just grabbing them and dragging them around. Like I'm not trying to get them to a specific XY right now. If I did want to get them to a specific XY, the way I would do that is one of a couple ways. Either I would change my grid to be something that corresponds with how I wanted to line up my parts, and then I would turn to snap on, so it would be snap to grid, and then I would move everything such that it snapped to that grid. Or I can go into the part and I can enter exact XY coordinates for a given part. And so I can say, okay, I want this part, you know, instead of -15, I want it to be at -12, right? And I'm going to click save, and it'll move the part exactly to those XY coordinates for me. So that part is now exactly where I told it to be. And if I move it, it obviously it's going to move according to the guides or the grid or whatever mode I'm in. But hopefully that kind of answers those questions. But I'm not moving stuff very accurately right now. But if you need to, Upverter does support that. Any others?
Oh yeah, I have a whole lot of questions.
Perfect.
Oh yeah, there's a bunch. How do you edge castellations?
Sorry, how do I add what?
Edge castellations?
Edge castellations. I don't know what that is. Okay. I can look. Let's see here. Oh, okay, sure. You would. So okay, this is for pads that are. There's kind of this thing that's quite popular in dev boards where you kind of have these hybrid pads. It's both kind of a surface mount through-hole pad, and so you can either just take a board like a PCB that has these kind of castellated pads and solder it directly onto another circuit board, or you can kind of like put pins in them and use it as like a dev board. It's quite a popular thing. You would do that all in the component editor. So and we have a couple of examples of parts like this. I can share some of those after the webinar. Easiest is probably just to start with one of those parts, fork it, and then you can reuse the pad design that they've already put into the part. But if I go back to the schematic, if I go back to sorry, not schematic editor, the part editor. So if I open this part back up, the way you would do this is you would add, sorry, I gotta go to footprint. You would add pads. This is my pad stack tool, and you configure the location of the pad stack and all that kind of stuff. You would create the pad, and then you would create a through hole and put it on the edge of that pad. So if I just very quickly, what do I want? I want, yeah. So if I had a pad like that, and then I went and added a through hole, and then put that through hole on the edge of the pad. Whoops, come on. Oh, I gotta move it manually. Anyways, you get the idea. Move that through hole to the edge of the pad, and then put that part on my board so that it was getting cut like right there where that dotted line is. That you would get a castellated pad. That's how you would do that. Okay, Livy, more.
Oh yeah. So will a parts editor allow a novice to add a complex part?
Yes, yes. Let me go back in there. We try to make it really, really easy. Let me, I'll edit a different part. Actually, here's what we'll do. We'll just go to my dashboard, and we'll make a part from scratch. That'll be more representative. So if I go in here and I say, okay, I want to create a part. So the way you make a part is pretty simple. You go in here, and this is our library of template symbols. So, you know, let's say you wanted to make a diode. So you're going to grab that, and that's your diode. Next thing you're going to do is go in here, and you're going to name your pins. It's a diode, so it's probably 1 and 2. Click Save, and then I'm going to set those pins on this symbol. I'm going to say that's pin 1, and that's pin 2, right? And so now my symbol is the way I want my symbol to be. I can set up my attributes. So like, let's say I want to give it a part number, and it's made by whoever, Diode Inc. Right? So there's my, oh, and I probably want to change the reference designator prefix, so it's a D, save. So there's my diode. That's going to do kind of everything you need from a symbol perspective. If I flip over to the footprint and I go in here to the generator, so that's this little foot here on the top left, this will generate probably almost anything you need in the world. So in this case, let's say it's an axial 2-lead generator diode, so I'm going to do that. Boom, there it is. I saved the part. I'm done. That's my part. You know, if you needed to make any tweaks to it, dig in any deeper, you absolutely can do that. If you kind of get above and beyond your level, the concierge is always available to help. But, you know, this generator will generate very complicated parts. So like if you wanted, you know, like a DFN with a ton of pins, like it'll generate that for you. And this table down here is in most data sheets. So making a part is really simple as you open up the data sheet, you find these numbers, you put them in this table, and you click generate, and you're going to have that footprint. If you need a BGA, we generate BGAs as well. Oh, sorry, I got to put rows. So like, you know, let's say it's a 10 by 10 BGA. Oh, my pitch. Sorry, apologize. Package length is 100. 100. Package height is 1. Say, there we go. So there's my BGA, and it'll generate that. And these are weird shaped pins because of those numbers I put in are not sensible numbers. But the BGA generator will generate parts for you. You just have to copy the information in and out of the data sheet. So yeah, you can do just about anything in the component editor. It's, you know, it will take you a couple of minutes just to get the hang of it, but you're not gonna cut yourself. It's gonna get you what you need in the end. And we have measurement tools in all of our tools. So if you wanted to check and just make sure that, you know, that your pins are the right distance apart, you can do that. And so, you know, generate it, check it with the measurement tool, tweak it, do it again, and eventually you'll get there.
So along with that, what is the cost for the concierge part design service? And I guess specifically for just a single part for a hobbyist.
Yeah, so we give you, I think it's 3 nowadays for free when you sign up, and so you can use those in 2 ways, and they're absolutely free. You just create the account, use them free. And you can use those in 2 ways. You can use a part out of the library, and it'll tell you it's unverified, and you can click the verify. There's normally a verify button. I've already clicked it, but I can add a new part and show you what that looks like. So you can use it that way. So you use a part out of the library that's not verified. You go into it, you click create and verify. So that's one way you can use it. Use your free credits. The other way you can use it is to request parts from scratch. Parts get charged based on how complicated they are. So very, very simple parts, resistors, capacitors, that kind of stuff, are quite cheap. They're, $15, I think, is kind of the average price for a resistor. But it goes up from there, like average kind of 8 to 20 pin part. You're looking, 20 to 30, maybe $40. And then like as you get up into like the hundreds of pin parts, you're talking like $100 or $200, something like that. But it's all complexity based. We give you the free to start with, so I really recommend, like, as a hobbyist, use those 3 free ones, because like they're you can use them on whatever you want. You can use them on the most complicated part you've ever considered, and it's still free. So use them. But when you run out of those, it's going to cost you. I think our average these days is maybe $30 a part. So $30 a part.
Okay. And then the parts that have been designed, is that design compatible or exportable with any other designers?
Sorry, are parts portable? Is that the question? Like outside of Upverter portable?
Yeah.
Yeah. So, well, yeah. I guess I can kind of answer this in 2 different ways. So one answer is every part that gets requested from the concierge goes back into the Upverter library. So like if you request a part, it goes back into the library for the benefit of, everyone that uses Upverter. So any part that gets created by the concierge ends up in the library. That's how we got the 1.4-ish million parts in the library, are just that people used parts, people made parts, people requested parts, and it all accumulated together into this very large library. So that's kind of one answer, is anything you use, anything you request is going to go into that library forever, and everybody's going to be able to use it. The other answer is we have a different product. It's not an Upverter product. It's not Upverter. It's called EE Concierge, and it's just our concierge, but it's for non-Upverter users. So if you use Eagle or Altium or any of those other tools, you can buy parts from the concierge, even though they don't live inside. Like, even though the concierge isn't built for your tool, you can export parts out of the Upverter library using that product. So I don't want to talk too much about that, because we're trying to focus on Upverter today. But yes is the answer. You can export parts out of Upverter. You have to use our other product to do it. And
what about the design in general?
Oh yeah, of course. So this is my project. Like, there's no save button or anything. Like, I don't have to do anything with this. I'm just gonna click over to the I'm gonna just click over to the project overview page. And this is going to be kind of where I do all the meta things to my design. It's where I invite collaborators. It's where I, share it. It's where I do all that kind of stuff. So you can see the history of the design here. Been through 429 little edits, and you can actually play that forward and backwards and watch all the changes that happened to the design. It's kind of neat. See the schematic, see the layout. It's all here. I got my whole bill of materials here. And then at the very bottom of this page, I have all my design data that I can export in just a whole bunch of formats. So we've got an open source format that you can take. It's JSON. If you like to hack on stuff, you can take that format and you can make changes to it. You can upload it back into the editor, and that all works. You can get Gerbers to take them to manufacturer drill files, XY position information for pick and place. You can take a PDF for the 3D step model, whatever you want. It's all here. So this is I think what they're asking about. It's, there's a ton of options. You can get the spice, for simulate all kinds of stuff. So that's all here.
Okay. So I have a bunch more questions, but I want you to finish getting through what you need to get through before we continue. So I'm going to let you go ahead.
So actually, let me just really quick, this just happened. Patrick, who's sitting next to me, runs our concierge, and one of the parts wasn't quite finished in time for the demo, and has just finished it. I just want to show you really quickly, this is what happens when a part inside the Upverter database gets updated. So this was an unverified part, which has now been verified. And so it turns yellow like this to warn me that there's an update for it. This will be a breaking update. It will disconnect some of my traces just because the symbol is going to be different than it was before. But I can get this new version of the part, and I can actually see a diff on what got changed in the old version of the part and the new version of the part. So any time a part gets changed in the library, you know, I can see which attributes changed. So look at all the attribute information it has now that it didn't used to have before. You know, here's the symbol change that's happened. And then here's the, whoops, sorry, I gotta scroll on this side. Where'd it go? There it is. And here's the footprint change, right? So this is before and this is after. And so, and, you know, it has a 3D model now and all kinds of good stuff like that. So anyway, anytime a part in the library gets an update, you get to see the update. You can choose whether or not you want to take the update and update it in your library. So that's just kind of, again, another kind of neat thing that happens because we're in the cloud, because we've got this big database of parts. But anyways, I'll just really quickly, because I want to answer you guys' questions, because that seems way more important. You guys kind of got the flavor of the tool. The only other tool I was going to show you, so this is the layout tool. I kind of walked through most of that. I showed you pores. I showed you kind of how everything works there. So don't, you know, so you guys got the idea on how you would ever finish that. Quickly, I wanted to show you the constraints tool. So this is, you know, these are all of the rules inside the editor. You can turn all the defaults on and off. You can add new rules. So like, let's say you wanted to length match a couple of traces. You know, you can go in here, you know, and say, I want my 5-volt net and my 3-volt 3 net to be length match. You would never do this, obviously, but you could say that. You could say what tolerance it's allowed to have and all that kind of stuff. And you can set up all these custom rules. You can make clearances, minimum clearances on particular layers or on other layers, all that kind of stuff. So this is how, as you kind of move beyond a simple RFID shield and you want to work on pretty complicated stuff, you got some high-speed traces, you've got a bunch more layers, you've got things like that. This is how you make the editor work for you. This is how you kind of say, all right, I want you to warn me when this isn't right. I want you to help guide these traces to make them the right length. All that kind of stuff happens inside the constraints editor. That's what this does. And then the only other tool we have, and I'll answer some more questions. But this is, we've got a 3D viewer built in to Upverter. It's currently generating my design. It takes a couple of minutes. I'm going to leave this open and generating while I answer a few more questions. And hopefully before we're done, you guys can see the 3D model of our layout. Every time you change the layout, it has to regenerate. So it is a little slow. We're working on making it more real time, and it's going to be more powerful in the future. But right now, that's kind of how this works. I'll show you that in a second as soon as it's done generating. But Libby, that's it. That's everything. So let's answer some questions.
All right. So how do you control layers?
How do you control layers? So if you go in here, so you can control visibility with these buttons on the right-hand side. You can also flip the whole board, so you look at the bottom instead of the top. And you can edit the stack up here. So you can see all the kind of the fixed layers here at top and the fixed layers here at the bottom. And then in the middle here, I can add layers. So this is layer 2, you know, and this is layer 3. And let's say I want to have a ground and a power. And I click save. So now I have a 6-layer board. And I can go down here and I can see into my stack up has been inserted my internal layers. So, and I can change the color of them and say, okay, I want this one to be green, I want this one to be yellow, and my ground can be blue, and my power will be red. And I can turn them on and off now, same as before. I can actually, if I go back into the stack up and I'm like, well, I really don't like that. I really should have had, you know, my power and ground right in the middle. I'm going to drag layer 3 down to the bottom. You can do that. Click save, and now your stack up's in a different order than it was before. But that's how you do that. In terms of when you're adding copper, so now that we have all these layers, I am on layer 1 right now. I can either pick the layer on the right-hand side that I want to be routing on, or we really like the keyboard shortcuts. You can push 2, and now I'm on my ground layer. I can push 3, power, layer 3 there, and I can hop between layers this way. So now I'm on my bottom copper. And what will actually happen is, like, let's say I start a trace on the bottom layer, and I'm like, okay, now I need to go up to the top layer, and I'm going to keep writing that trace. We'll automatically insert that via for you, and so this is a via that goes through all the layers that we just talked about, and it starts on the top and ends on the bottom. So that's how you do that while you're routing. So for example, if you needed to hop over a trace, I'm just going to get rid of this really quick here. So like, let's say I need to go, I'm going to start on one, and I'm going to go here, boom, boom. I'm going to go down to the bottom. I'm going to go over that, and I'm going to click again, and then I'm going to go back to the top. I'm going to zip over here. And we'll do all that. And I wiggled my mouse a little bit here, so we'll put that via back in the right spot. But that's how you would jump between layers.
Okay, and then I have a couple of people asking about auto routing.
Yeah. So we do not have an auto router. We have the layout concierge, which we're starting to experiment with, and that's the closest thing we can offer to an auto router. We over the years, we've talked many times about doing an auto router. They tend to be really shitty though, and we didn't really want to build an auto router that would just, that would suck, because like the way we saw this going is you're going to build an auto router, people are going to say, oh, amazing, you have an auto router, they're going to click the button, and then the complaint's going to switch from why don't you have an auto router to be why is the auto router so shitty, and and we didn't have the years and years and years to invest in making like a really good, powerful, artificially intelligent auto router, but we're working on it. So what we want to do is we're going to use the layout concierge. We're trying to learn a bunch about routing using that layout concierge, and all of that's going to go back in to the software, and we're going to eventually have an actual auto router that's based on all of our learnings and all of the things that we've discovered by doing the layout concierge. So today, yes, you can have the experience of click a button, wait a little bit of time, and your board gets laid out for you. It just costs money today, and it costs money because of the layout concierge. Eventually, it will be free, but right now, we just haven't built the software yet. So we're kind of in the manual phase. Eventually, we will be in the automated phase. You can, however, export your design out of Upverter and use any other auto router, and you can do all that. That's all an option. But but today, no. Today, no. There's no magic button other than the layout concierge button inside the editor.
Okay. So the next one is, how do you create a new footprint?
How do you create a new footprint? So we don't have separate symbols and footprints. They're all just parts inside Upverter. So if you want, an LED and it has a symbol, it has a footprint, it has a 3D model, it has all of that stuff together. You don't just, create footprints, create symbols, and then like map them together on the fly. We found that to be a really messy way of doing things, and so we changed that a little bit. And so you do it. To make a footprint, you use that component editor that I showed you earlier. You make your symbol, and then you make the footprint for that specific part in the component editor, and then that's your part. So you can't just make like a generic 0402 footprint inside Upverter. You can, however, use what we call generics. And a generic, so like let's say I wanted a generic resistor, I place that generic resistor down. I can go into the properties of this part, and I can pick an 0402 generic footprint. I click save, and now this resistor has it's a generic resistor that has a generic footprint, and so it'll be placed off to the side here. There it is. So there's my 0402 part I just added. So that's the closest thing we have to what you're asking about, is this idea of generics. But mostly we recommend people work with actual real parts, actual manufacturer part numbers. It'll make your life easier. And then in that case, when you make those parts, you have to make the whole part. You have to make the assembly, you have to make the footprint, you have to make everything.
All right, next question is, are all labels masked and in parentheses printed?
So yeah, so it depends on, it's the layer. So in this case, we've got a top silk screen and a bottom silk screen. So if I hide everything here, this is my silk screen layer, and everything that's on this layer, and I can add more stuff to this layer. I can add graphics, and I can add lines and text and all that kind of stuff. Everything that's on that layer will get generated into the Gerber file for that layer, and then when you send that layer to your manufacturer, it will come out exactly as it looks inside of Upverter. So you don't have to do anything else. It's just most of this came with the parts, but if I want to add anything else, I can draw on this layer. I can add text to this layer. I can add graphics. I can do all that kind of stuff. So I think that's the question. That's how you do that.
Okay. Next one is Upverter documentation only in video form, or are there written documents that can be searched?
So we have a little bit of written documentation. Unfortunately, lots of it is a bit out of date. We did the video series, I don't know, maybe 18 months ago. We produced the video documentation series. It's definitely the most up-to-date stuff. There is written stuff. I can get a link to you guys after the webinar here with where the written documentation is, but it's admittedly it's a little bit out of date.
Okay. Perfect. So in the schematic view, when you search for components, there are thousands of results for some parts. Is there an easy way to know which one is the correct one without looking at all of them?
Yeah. Well, so okay, so like this is for like duplicates. So in the term of in the case of duplicates, which we are working very hard on cracking down on, and I apologize that they're still there. We're working on getting rid of the duplicates. The search will rank parts by a couple other things than just what you searched for. It'll rank parts based on how often they get used by other users and if they're verified or not and things like that. So when you do a search, probably the first result is the best result for that part, just because it's probably the most used part, it's probably verified, it's probably got all of these other features and characteristics. You can also narrow things down though. Like if you do search for a part, like if this is more like you search for, 10K and you're like, holy shit, there's a lot of 10K resistors. Like what am I supposed to do with this? You can narrow it down here on the left-hand side. So you can say, okay, well, I only want ones that have footprints because I don't want to make the footprint for it. And I want, I want a particular package size, so like I want it to be axial, and you can narrow down in this way, right? So like right now, this Yagyo part is a very common, it's a 10K carbon film axial resist. Like this is probably the part you want. This one up at the top, right? They do make a couple others. I can go from 5% to 1%. I can go to 0.1%. Like they do have other options here, but this is probably the part I want, the first one that showed up here. And I can continue to search and filter down if I want using this list on the left. And this list is dynamic. This is based on the attributes in the result set you got. So for resistors, resistance is going to show up in this list, whereas it wouldn't show up if I was searching for like an IC or something like this. So this uses dynamic list on the left to filter the results. That's the easiest way to find what you're looking for.
Okay. So another question is, do fab locations like OSH Park take your layout direct for PCB manufacturing?
Yeah, so Osh Park is probably the most popular place that people get Upverter PCBs manufactured. So like, yes, they'll take the Gerber files. They know what to do with them. They've seen them many, many, many thousands of times before. So, yep.
Oh. And then ThinkFan also has design rules per manufacturer. Can they be entered and enforced?
Yeah, you can enter in custom manufacturer-specific design rules. Someday, a thing we would love to be able to do is in the constraints list, make it possible for you to pick which manufacturer you're going to work with, and have that automatically import all those rules. We haven't gotten there yet, and I think it'd be super, super cool when we do get there, but we're just not there yet. But yes. Just go into the constraints, set up your clearances, set up your hole sizes, set up your minimum trace widths, all that kind of stuff. It'll take you 10 minutes. And then, yes, your board will show you all the violations for whatever manufacturer's constraints you've entered in here. But yes, that's exactly what this is for. So you use the constraints editor to do that.
And so does that mean that you can have multiple sets of constraints for different manufacturers?
So like, yeah, if you like in the same design,
Seed Studio?
So in the same design, you would have to look at each of the constraints and be like, okay, clearance, I'm gonna have to pick the most restrictive clearance of my set of possible manufacturers and enter that in. We don't have there's not like a Venn diagramming tool to the constraints. Like if you say the constraint is a minimum clearance of 0.15 millimeters, like that's it, that's the constraint. If seed is more stringent than OSH is on this, you're gonna have to change this, to be something else. So you would have to mentally do that. And when you edit each of these rules, but you only have to edit the rule once, right? So if you're like, okay, I'm gonna enter the clearance, these are my 3 possible manufacturers, who has the worst clearance? Okay, it's seed, I'm gonna enter seed's clearance into this field. So it would take you an extra couple minutes to do that, but no, again, we don't have like a preloaded set of constraints in here other than just defaults.
Mm-hmm. But could you, I guess, save a constraint setup and then to be reused and then, basically like templatize a constraint setup?
Oh, yeah. So the way you would do that is you'd fork your design because the constraints travel with the design. So when you go here to your design page and you fork a copy of that design, you'll get everything. You'll get the constraints, you'll get the schematic, you get the layout, you'll get all of it. You get every part that you used in the design. You get the whole thing. Easiest way to do that is if you're starting a new project. If you're starting a new project and you're like, okay, I want all the constraints from my last project, just fork it and then delete everything, and you'll still have the constraints.
Okay. All right. Can you view others' designs anywhere, like a seed template?
Yeah, yeah. So we've got this explore button now. Now we haven't yet added this to the Hackster integration. We're working on it. It will eventually show up. Apologies for it not being there yet. But if you go to Upverter proper and you click on explore, you'll see all the other designs that are public in the Upverter ecosystem, and you can actually search. So let's say you're looking for a specific part or a specific technology or whatever, you can enter that into the search bar here and it'll limit the list accordingly. And then for any of these designs, you can just go into the design and you can either open it up in the editor, in which case you're going to be read-only. You're not going to be able to change it, but you can see what they've done. But you could also fork a copy of the design. You can watch the design so that every time they make changes to the design, you get notified, things like that. So like this guy's done a lot of work. He's done 8,700 actions. And we can actually watch the history of his design and see what those actions were through the viewer here. And it's just loading right now, but as soon as it loads a little bit of that history, it'll actually unwind his whole design. You can see all the work he's done on this design. You can fork a copy of it. You can do all that kind of stuff. So yeah. Yep.
All right, perfect. And then what kind of designs can you import? If he downloads something off of OshPart, can he import it?
Yeah. So you can. So not probably OshPart because those are Gerber files, but Eagle files, Altium files, and Cadence, OrCAD, and Allegro files can all be imported into Upverter. So if you have any of those files, you can import them into Upverter. To do that, you just go to your dashboard and you click the Create New Project button. And then as you're creating the project, there's this little Choose Files button, and you just pick the files here, and we'll import them. And the import is really good. It's unfortunately not 100% perfect all the time. You won't have weird problems. It'll either work or it won't work, but in a few cases it doesn't work. But like most designs would import perfectly, and you'll have everything you need, and you'll be able to use it and edit on top of it inside of the Upverter webinar. Yep.
He's asking for, oh, never mind. And then I think the last question was just about the integration between Upverter and Hackster. I guess there have been some challenges of the integration not working very well. It was stalling some stuff. And so what would be the best way to address some of those challenges that our users have had?
Oh yeah, well, so we just we didn't know that, so now that we know that, we'll work. So Ryan. So Ryan, one of our engineers, is the one that built the Hackster integration, and we had a couple of problems early on just because the Hackster spec changed a few times, and we were one of the first to do this integration, so that's all pretty understandable and expected. So anyways, things were just in a little bit of flux. If that's still happening, all we have to do is we just need to get Ryan to take another look at it, and he can work with Ben and and the guys on the Hackster team to figure out what's going on. But yeah, that shouldn't be a problem. In terms of the integration is really simple. Like, all we're doing is a user handshake. So everything else is inside the actual Upverter editor. You're just running our JavaScript. So if it's a problem with the Upverter editor, just let us know, support@upverter.com or the forum or somewhere. Tell us what's going on and we'll fix it. If it's with the user handshake, then Ryan and Ben just need to work together to figure that out.
Yeah, one of the guys said that it was stuck at creating splines. Am I saying that right? Probably not.
Oh, okay. So yeah, that's the editor not loading. That's, for some reason, the editor's not loading. And it's it could be a bunch of reasons. Like, we sometimes get this with like bad internet connections. We sometimes get this with like designs that are like malformed for some reason. Like, there's some bug in the actual design content and we have to go and fix something. There's a bunch of reasons. What we need is the design ID, and all that is in the it's in the URL here. So that ID, if you email that ID to support@upverter.com and say my design won't load, we'll fix it right away.
Okay, perfect. So I will make sure to communicate.
Or at least tell you what's going on. Yeah, or at least we can tell you why it's not loaded. Yep.
Okay. No, that would be great. I just wanted to make sure that we knew. So that the ID that you have highlighted right now, and then just email that to support@upverter.com. That's perfect. So great. Well, I think that.
And it's probably, yeah, it's probably something really simple. It's probably, and most of the time, it's not like a serious, scary thing. It's something dumb has happened, and they're normally pretty fast and easy to fix. So, yep.
Yeah. Okay, perfect. Well, I think that is all of the questions that we've got. So I think we got through a lot of good information that'll give all of our ambassadors a lot of ammunition for next month's events. So do you have anything else to say in closing, Zach?
I don't. I wish the 3D model had loaded. I apologize that you guys didn't get to see that. But I really recommend it. Like, go and look at the 3D model in one of your designs. It's really cool. It'll get better. But it's still pretty neat just to see what your board's going to look like when you get it fabbed. So, anyways, sorry you guys didn't get to see that. My apologies. This is a public design, the design I worked on. I'll get Libby to we'll figure out a way to share some stuff with you guys after the fact. But I'll get you the URL if you want to fork this design, if you want to keep working on it, if you want to do anything, you can do that. Because it's open and collaborative and upper, all that good stuff. So, anyways, but thanks guys. This was a lot of fun. I really appreciate you guys joining. Great questions. I hope I answered them. But try Upverter and we're here to help.
Yeah, and I have a little, just really short survey for after this, so that you guys can provide us with a little bit of feedback, stuff that you might have wanted to learn that you didn't, just some questions, anything like that. If you have any questions about this for me, you want to get in touch with us, just email me directly. It's just Libby@Hackster.io, or maybe it's Libby@Hackster.com. I don't remember my email address because I'm an idiot. Anyway,
I'm just Zach, ZAK@upverter.com. So if you want to email me, feel free, Zach at upverter.com.
Oh, I'm such a winner this morning. Okay. Well, anyway, you guys know how to get in touch with us. And yeah, so thank you guys so much for attending, and we hope this was really helpful.
Thanks, guys.
All right.